Okay, folks, this is the last one in this worksheet 1, and I think the things that are important here are that in my mind it doesn't have any velocity here. Again, this is something I think that is open to interpretation, but you would want to say, I just included the ball and the earth in my system. Double arrow here, dash line around. At A, let me put my things. At A, I said it was all EG. Pretty good at that. Okay, so A, I said it was all EG. I decided that it wasn't moving at that point of release. At B, what I think is important to notice is that it's squished. That causes two things. Certainly the hit with the ground means that energy goes to thermal, but also the ball is squished, and so the energy that was energy of height is elastic energy. Okay, then we go back up to C. We now have energy of height again, but it has to be less than we had before. We can't go up as high because we have lost some to thermal. Now, I know thermal is always increasing, and there are those of you who want it to increase from B to C. It certainly doesn't get less, but if we work this without air resistance, which I think is what I put in the hints, then from B to C it would not get more because there's no air resistance and there's no, encounter. Right, so it's the same, like a quarter. And at C it's still moving forward, so even though it's at the top of its rise, it does have some kinetic, right? But then when it hits the ground again at D, the thermal has to be more than it was before, right? And it compresses as spring energy again, but because it's lost a lot to thermal, it can't have as much spring as it had before. So there. And then when I get back up to E, it is still moving forward. I'm not really sure how fast it's going there. Now we're kind of guessing. We do know that it's still moving forward there. We do know that the thermal, I think, probably hasn't changed because we said no air resistance. If it was in real life, there would be air resistance. So I'm going to kind of make the thermal be the same as it was here. It changes from here to here because there's a hit. It changes from here to here because there's a hit with the ground deformation. All right, and then I've got more height again, but still I can't be at the highest height, right? So there we go. Does the ball, why not? Energy goes into the random molecules moving faster, so thermal.